Guys, so just a quick wrap up. We've talked about ionic and covalent bonds, but there's also ionic and covalent compounds. And the just really quick way to remember that we talk about this is covalent compounds are going to, similar to the bonds, they're going to share their electrons. It's going to be between two nonmetals. And a single unit is going to be called a molecule. And for ionic compounds, they are going to transfer their electrons, and it's usually between a metal and a nonmetal. And it can also contain a polyatomic ion, which is an ion that has more than one atom. Poly, meaning the word many, atomic, talking about atoms, so it's an ion with many atoms in it. And a list of polyatomics is on the back of your periodic table in the common ion sheets. And a single unit is called a formula unit. Now, if you are asked to decide whether or not something is ionic or covalent, like in these problems here, but you do not know their electronegativity values. Okay, so this is not using electronegativity values. The way to determine it is going to be through whether or not it contains metals or only nonmetals. And that will help you determine. So for example, sodium and chlorine, if you look on the periodic table, sodium is going to be a metal, chlorine is a nonmetal, so this will be an ionic compound. Now this is not always a perfect method, but it is how we determine it for naming and things like that, so it's going to be really important. Silicon is a metalloid and phosphorus is a nonmetal, so this would be a covalent compound. Magnesium chloride, magnesium is a metal, chlorine is a nonmetal, so this would be ionic. And an example of polyatomic ions, a real quick way to know is if you have more than two atoms, or excuse me, more than two elements in the compound, it's most likely going to have a polyatomic ion. So for example, if we look at problem number 5, we see we have K and we have NO3. That multiple oxygen situation there is a dead giveaway that it's going to be a polyatomic. But if you look on the back, you'll see that NO3 is an ion with a -1 charge, and it's called nitrate. And we know that potassium is a metal that can form a +1 charge, and so this would be an ionic compound. And so that is kind of how you do those, but we'll go back. P2O5 is going to be covalent, based on the fact that they're both nonmetals. If we look at aluminum and oxygen, we know that aluminum is a metal, oxygen is a nonmetal, so we have an ionic compound. Number 7, carbon and oxygen are both nonmetals, so it's covalent. Number 8, iron and oxygen, metal, nonmetal, so we have ionic. Carbon and chlorine are both nonmetals, so it's covalent. Zirconium is a metal, it's in that transition metal area, and sulfur is a nonmetal, so we have ionic. Phosphorus and bromine are both nonmetals, so it's covalent. Nitrogen and oxygen are nonmetals, so we have covalent. And then here we see that we have 1, 2, 3 types of elements. So if we look, this is actually going to have 2 polyatomic ions. If you look on the back of your periodic table, in the first column, you'll see NH4 with a +1 charge, which is ammonium. And you'll also see OH with a -1 charge, which is hydroxide. And so because we have ions, that makes it ionic. And then magnesium is a metal, and OH is again hydroxide, it's an ion, so that makes this ionic. So those are the ways that you would tell whether or not something is ionic or covalent if you don't have electronegativity values.